this video, we are going to explore some of the real use cases of the Google Gemini Pro Vision Model in the agriculture industry. So, we are going to build a plant disease detection control and prevention application using Gemini Pro Vision Model with a free API. And we are going to use the Gradio as the framework. So, you can push this further to build your own application that you can monetize in the agriculture industry or maybe sell it to farmers. So I'm going to take you step by step on how you can build this application using Gradio. All right, so I'm going to show you a demonstration of how this works. So we are going to upload. Right, so let's click on the upload. So let's upload a plant that is diseased. All right, so I uploaded the plant. Right, so this is an orange that has some diseases on it. All right, so let's see how the Google Gemini Pro Vision Model was able to analyze this disease plant. All right, so this application is able to break it down and it's able to give you the name of the analysis. It says citrus black spot analysis and the disease identification says the provided image exhibits symptoms consistent with citrus black spot, a fungal disease caused by the pathogen. There's a scientific name, Cognadia citricapa, and it's given the next one is the details finding. The CBS primarily affects citrus fruit, causing dark sunken lesion with yellow halos on the ring. So this is quite scientific here, right? And it says the next step is, so what is the next step once it has given the details finding? It says to manage the CBS, that is the citrus black spot. A comprehensive approach is necessary. Remove and destroy infected fruit to prevent further spread and implement cultural practices like proper irrigation, pruning, and sanitation to reduce humidity and improve air circulation. Apply fungicides as per local regulation and under the guidance of agriculture expert. And it's giving some recommendation. It says monitor the, the orchard regularly for early detection of symptoms. Use resistant rock, rock stocks and citrus varieties less susceptible to CBS. All right, and it's giving some disclaimer. Please note that the information provided is based on plant pathology analysis and should not replace professional agriculture advice. Consult with qualified agriculture expert before implementing any strategies. All right, guys, I think this is very useful. It's mostly gives you first-hand information, right? So if the disease is very serious or very harmful, you will need to contact a professional agriculture and seek an advice from there. All right, so let me upload the next image and let's see how this is going to come out. And let me do this one. All right, so this is the next one. Let's see how the Gemini Pro gives out information or analyze this image. And it says plant disease analysis report, the disease identification. The provided sample exhibits symptoms, characteristics of powdery mildew, a common fungal disease affecting grapevines. So he was able to identify it is a grapevine leaves. The disease is caused by the fungus. Oh, all right. So this scientific name, which thrives in warm, humid conditions. So it's giving the detailed finding, the next steps to manage powdery mildew effectively. It is crucial to remove and destroy infected plants to prevent further spread. And the recommendation says choose powdery mildew resistant grapevine varieties. All right, and it's given a disclaimer as well. All right, I see this to be very useful and really in the field of agriculture. It's really going to greatly assist farmers and even individuals to help detect some of the diseases that they might have no knowledge about. All right, so I'm going to show you how you can build this step by step. Right, right. So let's get into the VS Code. We are going to need to install the Gradio. We need this requirement, the Gradio for the framework, the Google Generative AI to connect to the Gemini Pro Vision Model, the Python.env to create our environment so that we can connect to the API. All right. So we need to create an environment like this one. So if you want to create an environment, you say pip install dash in order to say Python dash mvenv env. So when you hit enter, it should create an environment just like this one. All right, I have that created. All right, so we need to install these packages. So we are going to say pip install as our requirements txt. So when I hit enter, should install all the requirements. All right, so the next thing we need to do is let's get into the app. So it's app new one py. Can name it whatever name. We need to import the Google dot generative AI as gen AI. So from pathlib import path. So this is just to help us create our path. Okay. So we import radio as gr. So from env import load.env. So this just to call our create our environment, load our environment, and we import OS to create some path. So the next one is to let's load .env. It's going to help us load our environment API. So guys, I'm going to show you how you can do this. So we need to create a .env file. I've already created that. Right, so you create a .env, and in here is our API, the Google API key, and this is the API key. So let me quickly show you how you can grab that. So when you get to this link that's the makersuite.google.com, you go to create API key new project, and it should lead you to create a new API key here. Right, so it is very easy to set up. So once it's created, you copy that and you paste it here. Okay, all right, let's get back to the code. So now let's configure the API key using the loaded environment variable. All right, so let me say gen AI dot config. I think I made a mistake here. Gen AI. So when I say gen AI dot config, we are passing our API. So this is going to connect to our API key. That's the Google API key. I'm say get env. I'm going to say Google API key. Right. So when this is called, it's going to connect to the API key right here. Right. So it's really good when you have to save it in your .env. It's, so that it makes it safe, doesn't really get exposed. Right. So the next one is to let's set up the model configuration for the text generation. I'm going to say generation config is equal to, and let me start from here. We're going to pass the temperature. That's our temperature to be, we make it 0.4. You can change that whatever you want. The next one is the top E. I'm going to say 1. And my top K, I'm going to say 32. And my maximum max output, max output token, I'm going to say 4096. Right, so this is done. So the next one is, let me create a settings. So the settings, so we are going to define a safety setting for content generation. So I'm going to say safety settings is nothing but just to make sure the content that I am passing out is safe. So this criteria is going to help us with that. So in that we have the category. I already have videos on this one. Category. So we pass, I'm going to pass the save settings. So I'm going to say the harm category. So we have the harm category. Category. So I'm going for each has a criteria. I'm going to say category. Each has a category. Okay, so I'm going to pass it in here. And I'm going to pass threshold. And I'm going to say block. So if there's a harmful content that you are passing out, this is going to block it so that not going to be displayed. Okay, so threshold, category threshold, block. Okay, so now going into rate. going to say, so we are going to pass the category in each of these. So I'm going to say category in. I'm going to iterate through this. So these are the categories. I'm going to pass the harassment. So if the word is placed under harassment or the hate speech, I'm going to say hate speech. Hate speech, or it has this sexually explicit, contains words like that. Explicit or dangerous. Those words are dangerous. You know, there are certain words that are dangerous. It's going to block all of that. Let me see if I have everything that I need. Just change this to category. Category. I'm passing the, I think I need this. Category. I'm passing the threshold, the block medium and above. Okay, cool. So each of these words contains, if each of these settings contains any of these words, it's going to block it. It's not going to be displayed. So let's go to the next one. So let's initialize the model with this, the Gemini Pro Vision. So let's initialize it and pass the configuration and the safety settings. So I'm going to say model is equal to gen AI. Pass the generative model. I'm going to say model name. So the model name, you are using the Gemini Pro Vision, and the generation config is will be equal to the generation config that we have created right here. Right, so created that, and let's create a safety settings to be equal to the safety settings that we have created here. All right, so the next thing is let's create a function to read the image data from the file path. So let's say def read image. So this is how we want to read the image data. All right. So let me pass file path. So when I pass it, I'm going to say image path is equal to the path, create a file path. All right. So let's write an if statement. So if not image path, so if the image path doesn't exist, what do we do? Let's raise a file not found. Okay. Say say pass something, say could not find image. So we pass something like that. Could not find image. Let's pass the image path. Else. So let's return this what we want to return. It's going to be in a dictionary. So the MIME path, the MIME type, so it's nothing but it's just giving us the image. We want that in JPEG, right? So this is how we want it to be displayed. We want to get the data from the path, image path. We want to read that in byte. All right, so this nothing but a function to read the image. So we created a path and we want to get the data from the path and read it. Right, so let's create a function to generate a response based on the prompt and an image path. So we say def generate Gemini response. So let's pass a prompt and the image path. I want to pass the image path. Let's say image, create an image data. It's how we want to get it into the variable image data. So we say passing the function that we just created, right? And we say image path. So let's write the response is equal to model dot pass our generate content function, and in that we want to pass prompt and the image data. All right, and let's return the response as text. All right, so this is how we want to get the response. We pass the prompt and the image path, and we read the call the get the image read image data function where we pass the path to get the image data, and we pass it into the image, and we pass into the model generate content with a prompt to get the response in a text format. All right. So now let's input the prompt. So let's initialize input prompt for the plant pathologist. All right. So let's say input prompt is equal to, all right, have that here. Let me just, it's quite a long one. So let me just copy that. Decide to type is going to take a long time. All right, let me create it. All right, so this is how it looks. So as a highly skilled plant pathologist, your expertise is indispensable in our pursuit of maintaining optimal health. So you'll be provided with information or sample related to plant diseases, and your role involves conducting a detailed analysis to identify the specific issue, propose solution, and offer recommendation. So I have the analysis guideline. So you have to do a disease identification, detail finding, next step recommendation, important note, and a disclaimer. All right. So please note that the information provided is based. So you can just alter this information to meet your specific need. Right. All right. So let's move on to the next step. So let's create a function to process the uploaded files and generate the response from that. So let's process the uploaded file. Once the file is uploaded, let's pass the files. We want to say file path is equal to files. We want to get the one file, get the name, if files else none. So if there's no file else none, if there's a file, we want to get that file. And let's say response is equal to generate inputs. That's the input prompt. Inputs prompt and the file path. If file path. All right, so we say if file path else none. So we want to return file path and the response. All right, so guys, this is nothing but just processing the uploaded files. We want to get the first name, the first file, the name of the files, and pass the response function. We pass in the input prompt and the file path. If there's a file, we want to return the file path and the response. Right, so now let's generate the app. We are using the Gradio GL, passing the blocks. So let me say as a demo. So file output is equal to dr.s box. Oops. All right, let me clean this up. Image output is equal to gr image. We are creating a text box for the file output, and so this is where it's going to be displayed, and the output where the image is going to upload that. So we're going to combine outputs. So I'm going to say image output and file output. Okay, so let's upload the button for user to provide images. So we say upload button, user to upload images, gr upload button. So I'm going to say, let's write something and click to upload an image. say file types. So the type of the files, we are going to make it image, images, images, file count. We are going to do it multiple files. Right, great. So let's upload. So we set up the upload button. So that's going to trigger the processing function. Okay. So we say upload button dot upload, passing the process upload files, and passing the upload button and the combined output. All right. So we're almost done. So let me launch it. So we are going to say demo dot launch debug is equal to true to run it. All right. It's all set. Let me save it. Right. So quickly, just import these packages and we do a load.env to connect to load our API, and we create a config. We pass in the Google API key, which can be found here in the environment here. Okay, can be found here. Okay, so we set up the config, passing the temperature, passing the safety settings, and we create a model, Gemini Pro Vision Model. Okay, I think there is an error here. Let's see. Model, gen. Let's see. Gen AI, generative model, model name. There's a comma here, I think. Right, perfect. So another here. Right. So we create a function to read the image data from the file, and then we create a function to generate the response based on the prompt and the image path. So this is the prompt that we pass in, right? And we create another function that is going to process the uploaded files and generate a response. So we create a file path, we read the file and pass our response, and we pass the input prompt and the file path, and we want to return the file path and the response, and we create our application using the Gradio. All right, so let's save it again and run it. Just create. All right, so I'm going to run that by saying radio app, edit app new 1.5, hit enter. Okay, let me run it from here. All right, so let's try it and see how it goes. So I'm gonna do this one. We have an error. Okay, guys. So I think there's a mix here. All right. Yep. Read bytes. Okay. I think I should put an I here. Let's save it. Run it again. Upload. All right, guys. It worked. All right. So I uploaded this image. Seems to be a diseased plant. Right. It says plant pathology analysis report, disease identification. The provided sample exhibits symptoms of consistent with apple's cap, a fungal disease caused by pathogen Venturia inequilis, something like that. All right, it's giving the detailed findings, the next steps, the cultural practices, what you can implement to avoid this happening, prune infected branches, and promptly remove fallen leaves to reduce the inoculum's source, and chemical treatment. Apply fungicides with active ingredients like this and that, those scientific words. Recommendation to optimize plant health and prevent future outbreaks. Important note, these recommendations provided are based on general guidelines for apples cap, so site-specific conditions and local regulations may influence the appropriate disease management strategies. So consult with local agriculture experts. All right, guys, I see this to be very useful, especially in the agricultural sector. Yeah, so just feel free and play with this. And I'm going to put the code in my GitHub. It's already there, so you can find it there. And I hope you like this video. Do well to subscribe and share. And see you in the next one.